Block A of mass 8 kilograms and block B of mass 4 kilograms lie on two rough horizontal tables. The coefficient between A and table A is mu A. The coefficient between B and table B is mu B. Mu B is twice the value of mu A. So for example, imagine mu A was a third. This would mean that mu B is 2/3. That's all that is. Is that right? Coefficient of friction. Now, the blocks are connected by a light, inaccessible string which passes under a smooth, movable pulley of mass 12 kilograms. After the system is released from rest, the blocks in the pulley move and the string has a tension of 32 newtons. Okay, so let's start off with the movable pulley. What do we think is happening? 12G going down. Tension going up. But we know the T value is 32. Just keep that in mind when we're doing this, okay? Next thing. A and B obviously they'll accelerate inwards. A will accelerate at acceleration small a, and B will accelerate at acceleration. What's the acceleration of pulley, the middle pulley? Anybody tell me? Well done, it's the average of two of them. Somebody did a bit of study. It's the average of the two of them feeding in. So it's A plus B all over 2. Happy days. Okay, now that we have all this, actually, do you know what? I really like this diagram down here. Just save me going backwards and forwards. That's if it turns up. Come on. Okay, so what we're going to do is we're going to start off with some easy money here, okay? So what's happening is there's two forces at play here. There's friction, isn't there? Now what does it say the mass of A is? It's 8 kg. So it has an R value going up and 8G going down. And the friction will be, friction is mu R. So what's mu R in this case? Mu A 8G or 8 mu AG. Is that okay? Now what about for B? We'll call it N. And what's going downwards for B? What weight is B? 4 kilograms. So 4G. So what's the resistance of this one? Anybody tell me? It'll be mu B times N. And mu B is what? It's 2 mu A. And what's the N value? 4G. And what's 2 times 4 there? 8 mu A G. The friction in both of them is actually the same, but up in opposite directions, okay? Now it's called connected particles for a reason. So when you're considering particle A, you're only considering what's in this box. It has to be connected. Do you get what I'm saying? Now what direction is it going in again? Huh? Force. Ooh, why is it dotted? I do not want that dotted. Force is MA, and we're going to the right, aren't we? So what's its M value? M value? 8. Its A value? What's the acceleration of the A particle? Small a. What forces make it go to the right? Tension. What force makes it go to the left? Friction. 8 mu A G. Please all remember that T is what value? 32. We're going to do the same thing for B. What's the F value for B? Would you all agree it's 4B? And it's going to the going to the left. What force causes it to go to the left? No, that's the acceleration. Tension. Which is 32. What's opposing that motion? Anybody? 8 mu A G. Huh? It is minus. Don't know what I was thinking. Now lads, that's going to set up beautifully for a simultaneous, because I'm going to cancel off those 8 mu A G's. I'm going to get rid of them in a second. You'll see me, alright? Now the last thing we're going to target is this guy here. Everybody see this one? It's up versus down. Which direction is it going in? What's the only direction it can possibly go in? Down. So, force going downwards, yeah, is M, which is 12 kilograms times A plus B all over 2. We all agree that 12 divided by 2 is 6. So do you all agree it's 6A plus 6B? Now what causes it to go downwards? 12G going downwards. What causes it to go back upwards? 2 T's. Why is there 2 T's? And T is 32, so 64. Now guys, we have this on lock, okay? We're gonna do really well here. So this equation, which I'm highlighting here, it's the green equation. This one here, you're going to be the black equation. We have the red equation, the black equation, and the green equation. You see it? Now I'm going to work the red and the black equation off each other. I'm going to multiply the black equation by minus. And what happens when I multiply it by minus? Sorry, just these arrows are hurting my soul. Alright, so multiply by minus 4b minus 32 plus 8 what? Yeah. What happens when you add downwards? 8a minus 4b is 0. Okay. In that case, I believe that AA is the same as 4b. And in that case, I believe that B is actually equal to 2A. Take that energy and bring it into the green equation. What now? 12G minus 64 equals 6A, and then replace B with 2A. 12A. Let's go for this then. 18A. Somebody multiply 12 by 9.8 and then take away 64. 53.6, we're all saying? Okay. And would somebody be so kind as to divide 53.6 by 18 and give me the answer in fraction form, please? Thank you. That's perfect. That is exactly what's in the market scheme. 134 over 45. In that case, we now know that B is what then? Double the top. 268 over 45. And then what's the goal of the question again? Find out what mu B is. But to find out what mu B is, we'll just find out what mu A is. So why don't we use, see the red equation? See the red equation? 8A, which is 8 times 134 over 45 equals 32 minus 8 mu A times G, and G is 9.8. And what we're going to do here is, I suppose what we'll do is we'll do 8 times 134 over 45. We'll bring the 32 over and take it away. And then we'll have minus 8 times 9.8 times mu A. Then I'll keep the mu A where it is. And I'll do 8 times 134 over 45, take away 32, and I'll divide all of that by minus 8 times 9.8. Would somebody be so kind as to tell me what you get from UA in this case? 46 over. And we're going to double that for mu B, which will be 92 over. Can you give me that in decimal, please? I'm hoping it's 0.21. 0.21. Woohoo! Mu B sorted. You okay with that? And we're going to be pretty happy about this because in part 2, which is this part here, calculate the acceleration of the movable pulley. Well, the movable pulley is A plus B all over 2. And what did we say it was again? 134 over 45 plus double that, 268 over 45. And then divide the whole thing by 2. And what I'm hoping you get is 4.47 meters per second squared.